In this video, we're going to discuss how to find the derivative function algebraically. And this is going to build on the video where we looked at finding the instantaneous velocity algebraically. If you remember, instantaneous velocity is just another word for derivative. Notation-wise, f prime, that's what this little apostrophe here is pronounced as f prime of x, represents the derivative. And by definition, the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. If you remember, this part of the formula, called the difference quotient, is really just slope. And the reason we have to put the limit as h goes to 0 is because we want to take this secant line, and we want to take this point B, and we want it to get closer and closer to point A, so that eventually that secant line becomes the tangent line at point A. Because the derivative is the slope of the tangent line, and that's what this entire formula represents. Slope of the tangent line. And so it's very helpful if we can find a derivative function or a derivative equation so that we can find the derivative of a function at any point. And we're going to do that algebraically just like we did with instantaneous velocity. So it says find the derivative function of f of x equals 2x squared plus 1 algebraically. So we're going to set up that limit definition. Limit as h approaches 0, f of x plus h minus f of x over h. So once again, anytime there's something inside the parentheses, that means go to the function and replace the variable that's there with what's inside the parentheses. So I'm going to replace f of x plus h. That's going to turn into 2. So it was 2x squared. It's going to become 2x plus h squared plus 1. All of this is the f of x plus h. And so then we minus the original function, 2x squared plus 1, and you should always use parentheses around it when there's more than one term, all over h. And so because we're solving this algebraically, we're going to have to use algebra rules to solve this. So the first thing we're going to have to do is multiply x plus h times x plus h. We're going to have to double distribute, or FOIL as some people like to call it. So leave the 2 on the front. X plus h times x plus h becomes x squared plus 2xh plus h squared. If you need to pause the video here and FOIL off to the side to confirm this, feel free to do that. We're not teaching FOIL in this video, but if you're having trouble with the FOIL, make sure you ask in class. Bring down the plus 1, and I'm going to distribute my minus sign here so that I have a negative 2x squared and a minus 1 all over h. Then I'm going to distribute my 2. So I have 2x squared plus 4xh plus 2, oh, this should have been an h squared on the end here, plus 2h squared. And then the plus 1 and the minus 1 canceled out, and I'm going to bring down my minus 2x squared over h. And again, I'm going to combine like terms so that 2x squared and the negative 2x squared cancel out. And I'm left with a 4xh plus 2h squared. So the goal is always to get the h in the bottom to cancel out, and the way I can do that is by factoring out an h in the top, because all of the terms left in the top have an h in them. So I'm left with h times 4x plus 2h over h. My h's now cancel, which means I can now plug in 0 for the remaining h. I cannot plug in 0 until I cancel the h's out. Otherwise, I get 0 in the bottom of the fraction, which would make the limit undefined, or does not exist. So I am simply left with 4x plus 0, 4x plus 2 times 0, and so my answer is 4x. So at this point, I would like you to pause the video and try on your own, find the derivative of f of x equals 1 over x squared algebraically. When you have finished, unpause the video, and I will give you the answer. So the answer is f prime of x, remember prime represents derivative, is negative 2 over x cubed. If you did not get this, please bring your questions to class so we can discuss it.